So this here is the same beam as the last video, and we've already calculated the reaction forces. Now in this video we're going to calculate the key points that we need to draw our shear force diagram and bending moment diagram, and then we're going to actually draw those diagrams. So I'll show you what the diagrams should look like when completed. So here for the shear forces we're going to do the calculations, and I'm going to start from left to right. So I'm going to first take the shear force at, I'll put A plus now, and this really means just after reaction A. So that's what I need you to interpret A plus as. So just after reaction A, our shear force is just going to be 24.5 kilonewtons, which is really the same as that reaction force, and that's what we'd expect, because just after that point, that's the only force that we'll have. So now we're going to move along the UDL, and for the UDL we have every meter, at every meter for the UDL we're going to lose 5 kilonewtons of shear. So at 3 meters, and that's going to be just before the 12 kilonewtons, so I'm going to write that as SF for shear force at, I'll use C to mark that point, at C minus. So right here, that point, I'm labeling it at C. So at C minus, this is what we'll have. So we're going to have that 24.5 kilonewtons force that's going upward as our reaction force. And then going downward now is the UDL. So that is going to be 5 kilonewtons per meter, and it's 3 meter long, so 5 times 3. And that is going to take us to 15 from 24.5, so that's 9.5 kilonewtons. So remember, that was just before the point C there, where we have 3 meters. So we're going to go just after now. So shear force at, I'm going to put this as C plus to suggest it's just after point C. So shear force at C plus. So we're going to have that 9.5 at that point, that's going downward, but then in addition to that, we're going to have now that point load that's added, which is 12 kilonewtons going downwards. And that's what's going to take us into the negative territory. So this is going to be negative 2.5 kilonewtons. Okay, so far we are just after that 12 kilonewtons point, and we're going to go across now to reaction B. So let me just draw this up, and I'm going to call that at B minus. So shear force at B minus, so that's going to be just before reaction B. And at that point now, so remember our previous shear force was negative 2.5, and now at reaction B we're going to have, and I mean just before reaction B, we're going to have the UDL up to that point. So we're going to now be going down again by minus. So this 5 is for the 5 kilonewtons per meter, and if we go up from 3 meter to that end point at the 8 meter long, that's another 5. So it would be 5 multiplied by 5. So just before RB, we end up with, so 25, so this would be negative 27.5 kilonewtons. Okay, so this bit now is going to be shear force at B plus. So that's just after the reaction force. So at the point just after the reaction force, so remember before the reaction we were at negative 27.5, and then just after that now we're going to go up by this reaction force, which is 35.5, and that's going to take us all the way up to a positive 8 kilonewtons. And I hope you can see where this is going, because now I'm gonna go just at the tip of the overhang, and that point I'll just go just after that 8 kilonewtons. So I normally go just before and just after, but for now I'll just go just after that 8 kilonewtons. I'll show you what we have now. So this will be, I'm just going to write it as at the tip. So all this is going to be is we have that positive 8 going up and this negative force now going downward, so in the opposite direction really. So this lands us back at 0 kilonewtons, and this should tell us that our system is in equilibrium because we end up back at 0. So then on the shear force diagram, this is what we're going to plot. So this now is the shear force diagram that we would expect to plot, and I'll just talk you through the coordinates so you can see that it's the same values that we have used before. So right here, starting from that point, that's our 0, 0 point right there, which is basically our starting point, and you can see now where that goes up all the way to that 24.5 kilonewtons. And then at this next point right here, that's us coming back down at the 3 meter. So this would be our 3, 9.5 point. And then from there, we would have that sudden drop at the 12 kilonewtons. So that's where this now would come down to that negative 2.5 right there. So that would be 3 and negative 2.5 right there, that point. And then we'd be dropping further on with the UDL. And notice that for the UDL, I just draw that diagonal line that represents the gradual load for the UDL. And then that would take us all the way up back right here now to that 8, because there is no UDL, that would just go straight across and then drop right back to 0. So that's what we expect to see for the shear force diagram. Okay, so for the bending moment, we're going to take a section at each key point, and then we're going to sum the moments of everything to the left of the cut. So just as a key reminder that the moment, I think we have done this a few times, but the moment of the moment is equal to force multiplied by the perpendicular distance. So then I'm just going to use the purple line as my cut. So if we start then at A right here, that's my cut. And if you look to the left of A, there is nothing to the left of A, so we have no moment. So I'll just write this as bending moment at A is equal to 0. So I'm going to go across now to the cut at C. So that's basically taking us 3 meters in. And then we're going to look at to the left where we've got the reaction pushing up, and we've got 3 meters of UDL that's bearing down. So let's look at how we'll treat that now. So now I'm just shifting my cut across. So this is my cut, and I'm looking at everything to the left of the cut now. Okay, so this then is bending moment at C. So I'll have this 24.5 rotating like that. I'm going to take that to be a positive rotation, and it's 3 meters from a pivot point, which I'll just put that yellow point to be my pivot point, which is at the cut. So what I'll have then is 24.5, and that will be multiplied now by 3. But then what's going counter to that is my UDL. So I'll have to subtract now. This is for my UDL. So for the UDL, it's going to be 5 for 5 kilonewtons per meter multiplied by half the length. So I'll be doing 5 multiplied by 3. So that's the UDL now converted as a point load. And then I'll have to multiply that by half the length, which is going to be 1.5, so half of 3. So this first bit is 5 times 3, which is the UDL converted as a point load, and that 1.5 is the placement of that point load. And that's going to give me a value of 51 kilonewton meters for my UDL. So this time around, I'm going to take the bending moment at this point right here. So this is now my new cut right there at that next point where the force is. So that's at 8 meters. So what I'll have then is my 24.5 that's rotating clockwise. So that now will be 24.5, and its distance will increase to 8. Minus now, so this is now my UDL. So this is gonna be 5 kilonewtons per meter. So 5 now will be multiplied by 8. And this now is gonna be times half the distance, which is times 4. So that's taking care of the UDL. And then minus now, so that 12 kilonewtons, so that's 12 multiplied by its distance of 5. Then when we simplify that, this will be 196 minus 160 minus 60. So this gives us a negative 24 kilonewtons per kilonewton meters. So then we're gonna go for the last bit. So this is now bending moment at the tip. So the bending moment at the tip, so usually what happens is we don't even have to calculate this one because it's in equilibrium. So at the very tip, we expect that we'll end up with 0. So we'll have 4 values that we need to sort of subtract, and we will end up with 0. So I'm just gonna put that in. You can do the calculation, but it will definitely be 0. So that will be 0 kilonewton meter. And I'll show you now what the bending moment diagram will look like when we plot the coordinates. So this here is our bending moment diagram plotted, and this is our starting point. So that was our 0, 0, and then we got 51 kilonewton meters. We went down to 24, and then back up to 0. So that's our bending moment diagram. So hope this video was helpful, and if it was, then please subscribe to the channel, give the video a like as well.